Okay, so let's move to the second part of this workshop. Just as a kind of recap, again, what we talked about. We talked about the interface, and then, of course, the installation, like a kind of starting, and then the interface of the software. We talked about the um, panels, and then also the toolbar and the command line, and then also OSNAP, um, object snap panel on the left hand side. We talked about the kind of basics of the viewports, and then the basics of the construction plane, and then how we work with different viewports and then different view modes. And Also, we talked about a little bit of layers, and we reviewed some commands like the line, polyline, watt, and offset, um, copy, move, and mirror. A little bit of the scale, but also we talked about the just the very beginning of the 3D geometries like extrusion, and then what are the objects that we have. So we're going forward, and then we do a little bit more in a second. But um, what I would like you to do is just like using the units now. So we can use the units if you wish. So there is a command is called units, is under the property, actually document property panel, and that would be giving you a series of the different things that you can do. For example, the units. You can type, of course, properties, and then the whole window is going to come up. But I use units. I don't know. It's a kind of old habit, I guess. And um, under this panel and in this window, you're going to get so many different settings, including the units, including the grid size. So if you're wondering, so how you can change the grid size that you see on the viewports, we can change in here either on the active viewport or on all viewports. You can do some changes to the hatches and then line types if you wish, and then also some properties of the rendering units, and then also, for example, something on appearance, and then the colors that you're using. As some Most of the things that you use for the colors, it can be uh, accessible in here. Some of them, they're more advanced, so you have to write some codes or changing some of the codes, like part of the uh, internal kernel of the um, software, and many other things we can discuss later on. And let's go back to units first of all. So the units is really important because not only it is changing the unit from the standard to metric or unitless, if you wish, but also because of the amount of tolerance that you got in here. So if you have like the higher tolerance, meaning that you have like a smaller sort of object. If you have like the bigger objects, then you have a lower tolerance, because that is going to be associated with the amount of data that you record, and then you don't want to make it like so large. So for example, if you're working on a master plan project, you don't want to get like too much of the tolerance, and then just like so super accurate of and just like fraction of inches or something like that for like urban project. But if you're working on a furniture, and in that furniture you would like to develop it, so you have to have like more tolerance, and then a more accurate version of the units that you use. So, and then the other thing, if you notice that we have like two different types of units. One of them is for the model, the other one is for layout. So the model, meaning that whatever that we do in this window and here, this is called the model space. Also, we can have like the layout to print out our work. Let's say 11 by 17. I would like to uh, print it out as a PDF or send it to the printer. Then you can see, just like the layout for your board, or you can, just like always um, change or modify based on your need. And then you can say that a landscape is a portrait, so I would like to use a landscape, and then you can put all those drawings on the board and then send it to PDF printer or any other printer that you want. So we'll get to that part hopefully today. If not, then you can just like expect some type of videos that I'm working on to put it on my YouTube channel for your use later on, because I started the YouTube channel actually like last week after like 20 years of teaching. So for the usage of this thing. So I'm going to delete this for now. Then getting back to our units one more time. So I would like to change from centimeter right now, which is unitless because everything is fraction of 10. So it's working with the engineering sort of unit rather than architectural in this country. So you can change this, for example, to feet, and then let's see what's going to happen. I don't need that much of tolerance, but let it be, and then don't change it for now. And then you can have like the decimal, or you can have like fractional, or you can have a feet and inch system if you wish. And then the fractional, you're familiar with that, but it depends on what you would like to do. Anyway, so I'm going to use this and saying okay, and change unit system only. So meaning that your model is not going to be rescaled from centimeter to feet. So you don't want to change that, because as you remember in the first part of this session, you saw that I used something very similar to feet and inch system. So like 10 feet and then 15 feet, like making some lines. So then I don't want to change, and then I don't want to change everything. So I want to change the unit system and then maintain object sizes. So meaning that a centimeter box become something like foot, and then it's rescaling. But I don't want to rescale, right? I want to change the centimeter or unitless to feet, and then what we'll see in a second. Okay, and then if I go and then see in here and then get a distance, this is another command. It's called distance. So I'm going to get a distance from this endpoint to this endpoint. And then as you can see that we have like something around, because we changed this, we have like something around 23 feet from here to here. And then this is going to be a 3 feet for the door, the opening to the door, which is not that bad. And then this part, so this part from endpoint to endpoint, you have like 16 and a half, so 16 and a half feet that we have in here. So then you can start working with the unit if you wish. That's one. Let me undo this and then unit one more time. So let's distance this, and then from here to here now is centimeter. Yeah, that's good. So let me change this, and then just to show you what would be the difference. If I change this centimeter or unit less to feet, and then okay, then change unit system, and then maintain object sizes. So meaning that everything is going to be changed based on the um, um, unit change, and then unit, just like update. What's going to happen? You're going to see very different thing in here. So let me just get a distance in here. So the distance from here to here, look at this. This is only 9 inches, right? Because we changed that centimeter to feet and inch, but we rescaled everything. And then if you would like to rescale the drawing that you have from centimeter to feet, let's say you're working in Mexico, everything is metric, and then you would like to um, draw and then use that drawings in the States, then you have to use the second option. If you're working on a unit less and then you would like to make a unit based sort of drawing, then you need to choose the first option. Make sense? All right. Okay. So let's get back to our work. Uh, oh, okay. So we can give you some time, just like to um, restart it. Could you with Control Alt Delete and then go to the taskbar and then close the Rhino off and then reopen it again? Yes, unfortunately.
Click on Rhino A and then end task.
Yes, end task.
Oh, but which need the license number again?
Again?
Or
No,
no?
no, no, no. No, we enter that some time to time because they reset the entire system, then they needed that license again. It shouldn't be that one. Sorry about that. So we have to be careful and then save that. Let me save it just in case that I.
Save.
Oh, saved. Awesome. That's great. Nice. So you can change to whatever unit that you would like. Uh, s- uh, Mostly, I guess you use feet, right? So units and then units of the model. Yes. Uh, the more, yeah, the smaller object works for the more exact better, and then with more exact better. So meaning that you have like under a fraction of inch, or in the fraction of foot, or in the fraction of acre. So that is kind of just like the amount of the accuracy that you, because all of these softwares that we're using, no matter what, Rhino, AutoCAD, there is a tolerance because they are calculating something, and there is a kind of just like rounding up and down, and then even if you save everything, you can save it up to, let's say, 9 digit or 12 digit or 16 digit, not more than that. There is always a kind of fraction of the error. So that's why we always say that that tolerance is making a difference for the smaller object and the bigger object that we have. So then, um, okay. Then other thing is about units. Probably by changing the units, you would like to also, um, for example, if you use inches, then you need to change the grid too. Right? You can say that the multiplication of 10, no, I want the multiplication of 12 rather than 10, right? So I can say that instead of, just like inches that I'm going to use, so for 10, for minor degree, so minor grid line, so I would like to have like 12 of those. So you change that if you would like, if you're working in inches. So you would like to see the inches, and then each foot, you have like the major line, so you can change it to 12, and then so on and so forth. If you would like to manipulate the grid line. But in here, because I use um, a feet, I don't want to change anything. So that's fine. So every 10 feet that I have, like really, just like good sense of feet that I want, and then I don't need to do anything about that. So I guess we are all set on this side. And then I can undo my works just to make sure that I'm using a kind of, just like unit list that's really easier to handle in here, but you can stick to the units that you would like. So then um, also, let me see my list, because there are different commands that I would like to talk about. Okay. Where is my these guys? And enough. This is R. Um, Also, we talked about um, the gumball, and um, okay, so let's talk about like some other things, because it's really important to show you some of the a little bit more intermediate uh, understanding about our scene. First of all, I would like you to see um, the function key. So the function key F1 is going to give you the access to search for the help, and then you can search whatever that you need. So you can see that line, and then it's going to give you all different types of lines that you can draw, and then different methods for drawing a line. And it's going to give you it's a very thorough piece of document. F2 is going to give you the command history, and you can use that command history. So F3 is going to take you to the property panel. So the property panel. By default, if you do not select any property, any entity in your window, so the property panel is showing the properties for your viewports. So meaning that it's a camera, Look at this. So it's a camera, and then let me select one geometry. As soon as I select the geometry, then it's going to show the property for that geometry. Make sense? If I click outside, then it's going to show the property for the viewports, meaning that I can start working with the lens length of the camera that I'm looking at the object. So I would like to make it more dramatic sort of view and make it like 38. And then 38, meaning that you have like more, I mean, wider sort of angle. And then let's say 18 is super wide, so you can have a dramatic effect of your perspective.
So it changes the FOV.
Yes, that's right. So it's a focal length and an FOV, yes. And then also, not only that, you can make this instead of a perspective, you can make it parallel. So more of a kind of like an axonometric view, and then use it for your presentation. So the same thing you can take to the layout and then print it out, right? But not only that, also I would say, for example, uh, uh, capture this view that I have on Rhino. So there is a command is called view capture to file. So the exact same thing that you're seeing on your monitor, that you can capture that and then you can print it out. So then there are some controls. You can show the grids, and then you can show the axes, and then construction plane if you wish. If not, and then transparent background for the PNG files. You can take those PNG files and then you can add some background to that and then take it to Photoshop. You're familiar with PNG files, right? Okay. So then also, this is a HD by default 1920 by 1080 sort of resolution. If you're familiar with resolution and then how many dots that we have along the width and in height of your image, so this is that property of your final outcome of this command. If you would like, you can change this and then you can increase this. And let's say instead of 1920, I would like to go with 2400, meaning that I'm going to have like a larger sort of, and then it's a higher resolution. So you can print it larger, right? So you're familiar with resolution, right? No? All right. So I'm going to talk about that in a second on Photoshop, because we need to go to Photoshop. So let me save 1920 right now by 1080, which is the HD, is called as HD. Then I'm going to save this, and the scale is 1, and it is pixel, not the inches or centimeter or millimeter or feet or inch or something like that. So don't use that. Only pixel. All right. If you change it to inch, then it's going to give you a DPI. So that is different, right? So you can say that I want to have this size, and then 200 DPI or 300 DPI going to give me that kind of outcome. So you can do that. But I'm going to give you a kind of understanding about the pixel, and then because most of the time that you use pixels and then work with the pixels. So then, okay, and then is going to have your desktop ready in here. Let me go to make a kind of I'm going to make this as the first the small viewport output. Oh, sorry. Put it in. So small viewport output 01 or small. That's fine. So then the second one would be large one, so we can understand what's going on. Then run it again one more time by pressing enter, and then I'm going to change this and increase it to uh, let's say UHD, UHD resolution, so you can get that. And that resolution is 3840 by 2160, right? I'm gonna use this. This is HD, UHD, and then this is HD. You remember that HD and then UHD. So HD is 1920 by 1080, and then Ultra HD is this number. So I'm gonna use this number to add it in here, 3840 by 2160, 2160, right? And that is the same aspect ratio of HE, the same aspect ratio. You're familiar with aspect ratio, right? Aspect ratio meaning that the ratio of the width to the height, right? Aspect ratio. So we call it like 16 to 9, 9:16. So we use these days the monitors like the 9 to 16 or 9 column 16. So then save this also as the large one, large, or UHD would be better. UHD, and save this one as HD. Let's do this, would be more clear to you guys later on if you would like to review some stuff. And then this is UHD. Save it. It takes a little bit of time to save because it's a huge file somehow. And let's go to our desktop, and then on our desktop we can see that these are two files. So one of them is HD, the other one is UHD. And then let's open this in Photoshop and then see what's going on in here. So we're going to open it with Photoshop, the HD file, and then also Ultra HD file. It's not opening. Could you go to the search part of Windows? It was Windows 10, I guess. So go to the search part and then search uh, Photoshop. It's not downloaded. Yeah, creative would be good. So okay, so let me just open the other one also with. Uh, so we have two files. Open. One of them is HD. The other one is Ultra HD.
So after you enter settings, you just click OK.
Yes. And then you have the file name and then save it somewhere. So this is Rhino. Enter. So you do the settings, whatever setting that you have. Okay. Then it's gonna ask you where you would like to save it, and then what would be the name of that?
I'll click OK for like the files that show
Where did you download it? Oh, it never showed because it's probably the RAM issue. It's like the small RAM computer, so don't make it like too large. So because it takes a lot of processor. So make this, yeah, make this a smaller, like HD. Make this, yeah, that's what is good. So that's this is I'm going to reinstall that. So you can you can change the computer if you want, but yeah, you can pay attention also to this. And then let's see. Okay. Hmm. Okay. So I guess it's a kind of issue with saving something on that computer. Probably. Could you save the file on the computer? So weird. This- yeah. The only problem that we had sometimes is because of the size of the files. This is first time that I've seen that. Anyway, so let's pay attention to this, and then you can figure it out later. Oh, you're opening up? Okay, cool. So because you're a student, you have access to the online Photoshop. So both of them. Yeah. Yeah, two separate files. So one and then two. So I would like to explain this, just like once and for all. So it's going to be really actually helpful. Working now? Okay. Pay attention to this. So again, I'm recording this. You can watch it later if you want, just like for you, because the first part we didn't record it for some reason. I don't know what happened. So, and then now I'm using something else, some other platform. So, Control Alt I, and then Control Alt C. So there are two different things. It's sometimes just like it's people mixing them up. Control Alt C it's going to take you to canvas size. So it's going to give you the canvas size. So meaning this is called the canvas in Photoshop, and this is the canvas size. So meaning that if you change the canvas size, let's change the canvas size to 3840 by 2160. So this is the canvas size, and then this is the file that we're working on is HD. So I change the canvas size to UHD. See what's happening. What is happening? So your canvas is going to be larger. Nothing's going to happen to your image, right? And then in here you have like 1920 by 1080 as the size that you have in here, right? Okay. And let me put it back just to make sure that we have like the difference. So this is much smaller than this one, because this one, if you go now to Control Alt I, so it's called the image size. It's another window. It's called image size. We're gonna give you the actual and an active number of the pixels that you have. We call them resolution, right? Don't pay attention to the size of the sheet or something like that. So first work with the resolution based on the pixel, then you can translate it to any size, right? So meaning that the only important thing is the number of the pixels. So the number of the pixels, if you look at this, the number of the pixels is 1920 by 1080. So you have this number of the active pixels. And if you look at this file and then look at the image size, you have 3840 by 2160, meaning that it has a higher resolution than the other one, right? What does it mean? It means that if I turn off the resample and then changing this to, for example, 200 dpi, because I would like to get a higher resolution for my print on my board. So this is the maximum size that I can get at 200 resolution, 200 dpi resolution. Let's say 300, so to go with the safer one. So this is the maximum size that I can get. So if getting bigger than this size, so you're going to have like the pixelated pixels on your board, and then when you print it out. So this is like 13 inches or by 7.2, so 12.8 by 7.2 at 300 dpi. So if you have a board of like 36 by 36 inch for your final presentation, and then you would like to have this guy on that board 36 by 36, right? And then the 36 by 36 at 300 dpi resolution, this is the maximum that you can get out of it. If you make this stretch this bigger, then you downsize the resolution, then you have like the pixelated sort of pixels, right? Then the outcome would not be really good. So let's say this is 13 by 7, and then if I do this to this file, that was the other one was like UHD, this one is HD. So then I'm going to turn off resample, then 300 dpi. Now this is the maximum size that we can get. It's 6.4 by 3.6. You cannot increase that. I know that some people say, oh, you know what, I want to make it bigger, so then resample this, and then I'm going to change this and make it like 20. You're gonna make it 20, but you're getting these pixelated edges and then picture, right? Although that there are some type of improvement, but that improvement is nothing very similar to getting a higher resolution from the rendering engine. So get the higher resolution from the rendering engine if you would like to print it out with the larger size. So then getting back to our work in here, depends on the final print version that you want. So you're going to set your resolution, like HD, UHD, Full HD, 4K, whatever. So, and then also you can just get a sense of what we can do in here. And then, for example, this one also, I can get a view capture to file. And let me, this time, instead of using a JPEG file, I'm going to use a PNG file. So, meaning that the background is transparent. Then, this is going to be a PNG file, and it's a UHD PNG of the viewport. So what's going to happen if I go back to, let's give it a little bit of time. I'm going to go back to my drawings in here, and this is my PNG file. I'm going to open the PNG file, and as you can see, back behind it is transparent. So you can add any type of color if you like, or any other type of overlapping. So it's not overlapping just because we don't like overlapping that much, I would say, as the designers and architect. But you can add like colors, you can add like some type of, just like perhaps trees or skies, and then you can start editing your file. Uh, huh? Sure, yeah. So this is our drawing in here. Then view capture to file, instead of just like a JPEG, I would go with PNG, transparent background. So okay, so okay, on Photoshop. So on Photoshop, what you need to do is just like open up the file, make a layer, and then move the layer underneath the layer that you have. Then add any color and then fill that. It's like, let's say, fill it with any color that you want. So color, I change it from background, foreground to color, and then I set up the color in here, and okay, and then okay. So now this is my background color. It's coming up, and then my drawing is on top of that. Make sense? So open up your um, file. So this is your file. Opening up in Photoshop, right? So make a layer, make a new layer, and then because by default is gonna come up on top of the original layer that you have, like drag them underneath this one. Okay, make it be like gray, meaning that is active layer. Then go to edit, and then go to fill, and then use the any color, foreground, background, or color. I would like to use color to have control on that. Then you can change this to any color that you want, and then okay. Then the color has been picked, and then okay. Then you fill it. Oh, okay. So you can go to Windows. You can go to Windows. Uh, you can go to Windows, and then open up layers. Right. Cool. You got it. Nice. Beautiful. Yeah. So you can go to Windows and then turn on any window that you want. Good. Okay. All right. So um, let's move to the also one more thing, and then that is camera F6. Let's talk about function key F6 because we talk about F1, 2, 3, 4, 5. Let's just like leave it out for now. Go to F6, and then I'm going to change this back to perspective, and then lens length to 50 or FOV if you wish. So getting back, and then when you were in perspective and then press F6, the camera is going to come up, and then it shows the camera on and off. So this is the location of the camera looking at your object in perspective view, but it's showing it on the other views. So this is the location of your camera, meaning that if I moved, let me see if I can move. Not the geometry, so yeah, let me see that one. Toggle off.
Well, so whenever you orbit,
Mm-hmm.
does it always orbit around the center of your like entire mass?
When you orbit it, so
Yeah, because like I can see your camera right here.
yeah.
So and that's the like where it's orbiting around.
Yes, exactly. So it's going around that. Yeah, that's right.
The like average of your whole thing.
Not the average. So the last geometry that you picked. So if you select this geometry, select this one. Yes, and then click on this. Look at this. Click on this. Look at this. Move to the other side and then make it. So it's the area that you work on. Then you have like those sort of changes. All right. Okay. So um. Okay. So now I have these. The camera also can be select, and then you can move the camera as you wish, and then you can say that, oh, you know what, I want to have this view. It doesn't need to be um, just the um, active view that you orbit around, so you can play with the camera. Also, you can move the location, and then also you can rotate it around. So that would be also really sometimes interesting if you wish. Oops, I guess I did some changes in here. All right. So and whenever you got lost, click on this, and then you're gonna get back to the original view. Click on this, and then F6. If I go to press F6 one more time, so the camera is going to turn off. If I'm on the top view, and the top view is active viewport, then press F6, then you're going to get the camera is looking at the top view. Look at this. So this is the camera that you're looking at the top view. Make sense? And then if you move around, then be careful. If you move around one of the points, then the entire, just like looking at that is going to change. So the top view is not going to be top view anymore. So because top view is perpendicular to the construction plane that you have, right? If you move it around, then you are making it as a parallel view, as like a sort of axonometric. So again, getting back in here, click on top, press F6 one more time to turn off the camera. I don't want the camera in here. So then if I press F6 in here, and I see the camera, changing the camera. So I would like to see the, for example, the property, and then that, the property for this view and I change this to from perspective to parallel, look at this. The camera is going to change. And instead of being a cone, it's going to be a box, meaning that it's parallel, everything. Right? Okay, so this way, easily you can say, you can get some axonometric view. So how you're going to do this? It's very easy. You make a box, and that box would be, let's say, 100 by 100 by 100. So this is a box. It's called box. 100 by 100 by 100. So you can go up, and this is going to be 100 the height. This is my box, and then I moved it. Anyway, so I move this anywhere that I want, and then I make it wireframe just to make sure that I can see everything inside this. Then I can go back to my um, top view, and then you can start playing with uh, the location of your camera, and then changing this location of your camera to go to the end point of this. Don't move it on the perspective. So this is the location of your camera, and then also you can set up your point to this point also, going down. There you go. So we have like one point in here, and then one point in here, moving it down. I know that we have like a kind of a little bit hard time to move this, but let me just this one. All right, there we go. So, and this one again, we have like the kind of issue with. Let me fix this because it's a little bit, just like tricky to add the camera. Yeah, that's it. So you got this, and then now we have the axonometric view for this. Getting back to our work, so perspective again one more time. I don't want to have anything else, so I can delete all these. Okay, that is good. And okay, perfect. Now reset it. Okay. Point curve surface subdimensions. Let's move to the next part, and that would be tool work customization, yes, application settings, and then yeah. Oops. Okay. I guess that I saved somewhere my file. Yeah. All right. So now we have all of them getting selected with cell object, and then this. And then reset. Yes. Okay. Yeah. Cool. Um. All right. And we talked about the camera too. And what else? Oh, F8. Um, so it's gonna give you ortho is on and off. Um, so F9 is gonna turn on and off the grid snap. F10 is gonna turn on the point. So I would like to talk about F10 and F11 in a second. Imagine that I have a curve because we didn't talk about curve to make sure that we're on the same page. So not making it very complex. This is a curve, and this is a system of recording curve. It's called nerves. That's why everything is based on mathematical equations. It's very interesting because you don't keep all the points, you keep the mathematical equation here. Then what you can do, we can start, just like manipulating the curve very easy. And to access to these points, you can turn off and turn on the points of the F10 and F11. F10 is turning on and then F11 is turned off. So this is the curve again one more time, and then you have like this curve, and then turn on the points so you can have access to the points of this curve, and then turn it on and turn it off if you want. And then let me do something really quick. So what we are doing and then why we are doing this, because it's the one of those actually the strength of this software. So F11, turn it off, move this guy up. It's just like a kind of another addition to what you've learned. So I would like to make a surface in here. So this was a solid geometry because we had it capped, and then there was no open surface. Then we can extrude this. If you remember, extrude and extrude curve. So you can extrude it, let's say by 25 feet. Or you can say that I would like to make a surface between these two curves and then adding it to my work. So let me do something really quick. I'm going to move this guy a little bit backward. Then I'm going to move this geometry, moving it from endpoint to this, and then also from endpoint to this geometry. Then I would like to make a surface in here. There's a kind of hypothetical sort of design that I have.
Explain the difference between F10 and 11. I'm sorry.
F10 is turning on the point. F11 is turning it off because you don't need all the time to see the points. So it's turning on and then turning off. Turning on the point, and then you have like control point on, and then you have like the control point turn off. So F11 turn off. So and then you can get a loft between these two geometry. So and then make a loft. So meaning that the surface is being built between these two. Okay, so you have the surface, and then of course that if you would like to do more, so you can do something. I don't know. Let's say you're designing a different version of, and then let's go to the 3D version of this. So we go to the front and then right, so we can draw something in here, and as you can see that when you move it this way to the front side, you can work only on the Z0. So Z0 is in here in the front window. I know it's a little bit hard to understand, but you have like construction plane on each surface, on each view different than the other one. So we have like everything set on the 0x for the front, on the 0y for the right, and then on the 0z for the top. To navigate through that, I know again at the beginning it's going to be hard to understand, but when you go forward, you understand it easily. So meaning that if I move my pointer and then my mouse to front, whatever that I'm going to draw, you can see that whatever I'm going to draw in here is going to be on the x0, x0. If I move it to right, whatever I'm going to draw in here, it's going to be on y0. So you cannot get away. So you look at this. So I draw something in here on the right. So then the construction plane is off of the y0, not any other number. So we can have like, so then what we can do to overcome this issue, I need to move my construction plane. So I need to move my construction plane. For example, let's say I have this guy extruding it, going up. Then I would like to draw something in here on this construction plane. So then I need to move my construction plane from y0. You can imagine that there are three construction planes, each of them starting from x0, y0, and a z0. So I need to move that. So what I need to do is just like going to construction plane and then go and then find the construction plane to object. So construction plane to object, and I use this object. Look at this, the construction plane moved around. So whatever now I'm going to do, so it's going to happen on this construction plane. Make sense? I know it's a little bit, confusing, but it's very easy to navigate when you get used to it. So,
Mine doesn't attach to the same issues. If I just have ortho one,
uh-huh.
no snap, it doesn't attach to the same. Like I can just make a straight line from it. And it must like this.
Yeah, you are on the top view. So if
Even
you
when
go
I'm
to
on
front, if you go to front, so yeah, you're supposed to off. There you go. So you always jump to that location. So you cannot get away from the x0. So it's x0.
my
So go to right. And you change the control.
I have
Let's see. So
but isn't
oh,
that like
because
better?
because you no, because you know just like there, but you no, it's not this one going up. So here the day, because you started with the point is not the z0. So because now it's the 3D version. But if you are working on this, whatever you do, look at this. Jump into x0.
You just do it on one.
Yeah. So in here, jumping on y0. But if you start with something other than C0, then you can move around. And then you cannot control it at all. So when you put it something in here, then you go to this view, it jump on the 0. If you go to this view, it jump on the 0. Because you were on the construction plane 0. It tries to keep it all 0. Right?
Okay. And to change that, you
Just to change it, so go to the construction plane and then mostly we use object. Yes. And then select the object that you would like to use it as a reference for that construction plane. So you can move that construction plane. And then you can draw something on that. Like let's say I would like to draw a window on this. How I'm gonna do this? I don't have any reference. So it's a wall. Then now I can draw a window on this. Easily. I know. I know. I know. Then I would like to split this. Split this. I know it's a little bit, just like confusing, but So so select the object to split, and then select the corner, and then edges. So you took it off. So this is the window that we have. Oh, be careful. So the original one, it's easy. So it's easy. So look at this. So you change the construction plane on the perspective, right? So click on the perspective, get back to the top world. So everything is going to get back again to the same. So in here. So the top world. Make sense?
So, okay, my thing is that my construction plane wasn't like straight. Because yours wasn't either. How did.
Why is that? The reason that you pick something like an object that is not straight. Yeah. So for that object, that's why every object has a construction plane itself. Then you use that for the construction plane. Instead of using it, use this one, for example.
Okay.
Yeah, for example, that one. Yes. There you go. Now, if you draw a rectangle, the rectangle is going to be drawn on that wall.
Oh,
so then you can split it, delete it, and then make a window into that.
What if I want it to attach to this?
To what? You cannot attach to a line. You can attach to a surface. So this is a surface. It's not a line. If you want to do this, so I can show you something. Yeah, exactly. I can show you in a second what you can do with that. So let's say you would like to do something with this. I'm going to loft this, and then loft it, and then you would like to do something with this line. So Control Shift and then select this. Control Shift and then select the edge, right? And then use this ball and then extract it. So you extract this. I'm gonna delete this one for a second. So you extrude this one. Now you can use this as an object. So everything is going to be on this object. Control Shift, hold Control Shift, and then extrude it. Select this one and extrude it. And then select this one and extrude it.
So how did you again do? Because yours is like lopsided. How did you do the straight wall?
So if you want to do the straight wall, so you have to have a straight line. If it's not a straight line, so you cannot do that. So how you're going to do this? Delete this, and then let's delete all of these surfaces. I'm going to show you how to do this. So I don't want, because this is like a double curved surface. It's a very complex geometry, right? So if you use this, let me get back to my top view. So this is the top view, construction plane. So I'm going to extrude this curve up, like let's say how much that we have, like to the end point of this, right? So this is my curve. Make sense? Okay, so now I can control shift and then move it back as much as I want. And then now this is my surface. So now I would like to draw a window on this, and then I'm going to select this object and then to this geometry in here. So if you would like to make a specific point, then also you can make a specific point too. So let's get to this part. So then you can draw a window in here. This is your window, and then copy paste it if you wish. Copy paste it, 1 and a 2 and a 3, right? Are we good? Okay, so we split this geometry with these, and then now you can delete them, or you can say that, for example, I would like to make some type of box getting back and then extrude them if you wish. It's in boxing. It's going inside this. These are the box going inside.
So you split.
I split, and you can delete them. Let's open it.
Oh, because
Yeah, because they're like two surfaces.
it doesn't work when I split it.
So you split the geometry, and then you use the cutting edges. So did you use rectangle?
Yeah. I time to split, select the face, and then I select this the rectangles.
I think you have to extrude.
Let me see.
So
So let me see this. This is like split this geometry. So I want to split this one. This is going to go in.
Oh.
Also, if you don't want to keep those splitted surfaces, in this case, so you can trim them. So trim the geometry that you have with those edges, and then trim them. There you go. So split, we can, because we use, sometimes we need them to make a pane, like a window pane or something like that. If you don't need them, so you can trim them. So then, getting back again to my construction plane from the top, and I can say that, for example, this one, I don't need it, and I would like to make a geometry in here. Let's say something like this. I don't know. It's just like, it's not a nice design right now, but that's fine, I guess. For our purpose, would be good. So this one, and let's go inside, and then this guy, and then you can say that I need to close this off because I would like to cap these. So now I can cap them. Let's see if we can cap this one, this one. All right, okay, so these are like separate surfaces, so I need to put them together. This one, let me turn off this, hide the geometry, and then unhide them. Hide the geometry, I unhide them. So I hide it, the um, walls that I have in the background. So pick these surfaces and then also hold shift and then add this one and then put them together with join. So now they are all joined. So now I can cap them to add a roof and a bottom floor to that. So and then you can unhide or show, sorry, show, and then show the geometry, and this would be the separate geometry from this guy. We can add whatever design that you have in here. And if you have like more complex surfaces, there are other tools. So you'll learn about the loft, and let's talk about a little bit more about some other tools too. Um, these are some of the other tools that you can work with. So this is a 4-point surface. You can make a surface out of 4 points, or you can make a surface out of 3 points, 3 and 4. And you also be able to patch some surfaces, like let's say something like this, and you would like to patch them and then make a surface out of something that is having like an irregular sort of shape. Are we good?
I think we're like trying to like catch up.
Okay, all right, sorry about that. So
Right now, I think we're trying to attach the curves.
oh, okay, attach it. So you're gonna have like time. Let's give you a kind of 5-6 minutes, just as a kind of. And what I would like to do.
There. It's just messing.
Are we good?
Yeah.
Do you need any help?
Nice. Beautiful. Yeah. Yeah, it's supposed to. There we go.
It's just like navigating around it.
I know it's a little bit, it's just like at the beginning. Yeah, it's a learning curve, like any other software. So let me show you something else, because based on what we worked on, and this is another system. Let's say this is like the curvature that you've been working on, and then you would like to add some walls back behind it, and let's say this one, and I'm gonna get tracking of that, and then closing it off, and that's it. So this is the shape. Pay attention to this part. This is really important. So I'm gonna do it again one more time because this is right really interesting. So this is a curve that I generated. I would like to make a wall back behind it. So using polyline. So using this, turn off your ortho, and then you can hold shift to use ortho if you need, and then orthogonal, and then go hover over this. Then it's going to be a tracking of this point, right? Then hold shift, and then click, and then endpoint. So you can have like perpendicular all of these to this one, and then now put them together and then joint them. So this is all joined. Now you can say that I would like to extrude it as a geometry. Make sense? It's really useful and then easy to do that. So that's why I'm showing you different method to develop. So we started with the plan, and then it's not all about plan and then extrude it, because you're gonna get trapped actually into like a boxy type of geometry. So then um, if you're okay, I'm gonna give you like a few more minutes to catch up if you wish.
At the roof. Really? Yeah.
Roof? What do you mean?
The top part of it.
So this one, so we extrude it.
Oh, okay.
So we extrude it. If you would like to work on a more complex geometry, always there are different things that you can do. So for example, you can copy this guy is going to come off. Then you're going to, let's say, manipulate some of those points if you wish, and then at the end you can loft them. You can loft them, and then you can cap them.
Oh, okay.
Loft and cap. So these are different methods of making geometries.
So
Depends on what you would like to do.
with the windows that we have, can you show how to copy them?
So these are two curves. You can loft them first, and then it's going to give you a kind of a starting point. If you're going to change the starting point, so the geometry that you're going to get is going to be different. Look at this. So then you can also rebuild this, make it like a curvature and a curvy shape, and then on the other side also is going to be this. But if I'm going to get back again to my original point, it's like matching and then corresponding with each other. So I'm going to get everything um, cut by the edges and the corners of the curve that I have. Then okay, this is going to be just the boundary. So you need to cap at CAP, cap that, and then it's going to be capped both sides. If there is a planar surface, we call them planar surface. Shouldn't be like this. If it's going to be something like this, there are other ways to cover that. If it's flat surface, you can cap it. If it's not a flat surface, there are other ways to do that, right? All right. And just do some um, exercise. What we do, I'm going to show you something interesting because this is very um, intense sort of workshop that we don't have time to focus on exercises or something like that. So later on, you can have like a probably more extensive like 2 day workshop with the exercises, and I'm going to give you some handouts um, if you wish. Um,
When you do the cap
uh huh.
with the windows,
With the windows, you cannot do the cap
okay, yeah, because they're
because they're open. So you have to have like a closed and then make it solid. So cap is making it solid. So meaning there is no opening to the outside, right? Then you can add the windows into that.
okay.
Mhm.
Would you just split the surfaces again?
Yes, you can redo the surface, explode it, redo the surface at this at the surface, and then put them together all together. You're using different techniques actually. I'm so happy.
This is yeah,
So,
yeah.
where was my in class? Okay. All right. So as a kind of recap of what you can do with Rhino, this is the it kind of mapped out about all type of surfaces that you can get with Rhino. So it's a surface with two corner. It's a rectangle surface. You can get the surface of the 3 point or 4 point, 3 point or 4 point. So this is 3 point and this is 4 point. You can rotate it around, so of course it's not only one way. So we can have like the planar surface like these guys, and then this is a patch. I'm gonna show you in a second. And then meaning that you can patch any type of just like geometry that you have. So this is the patch, and you patch this and then cover this. It's very interesting. And not only that, also you can have like patch based on the um, different type of order of the curves that you get. So meaning that the curve 0 and then curve 1, all the even curve they're going to patch, and then all the odd curves is not going to get patched, so it's going to be open. So meaning that you have inside this again, it's going to get patched again, and then we have like a degree of the from the top button. If you don't put everything on one planar surface, that is a very useful tool that we use it for our topography. So if you move them up, and then let's say these are the contour lines. These are the contour lines that we have, and we can patch all these together and then make a series of the surface, and then put a surface on top of that. So you can use this as the contour lines too. So then I'm going to show you in a second how you can do the entire topography. And we have like the surface from 2 or 3 or 4 curves. So 2 or 3 or 4 curves. How? So let's have a look at that. What we can do, I'm going to hide these. And um, let's say we have a curve in here, and then I have another curve in here. So these are two curves that I'm working on with this geometry. Then you have, oh, these are two curves, right? And I can get a surface from network of curves, or I can get a surface from 2 or 3 or 4. So 2, this is going to be my surface, right? I can also say that I'm going to have like another one. Let's say copy this from endpoint to endpoint. So now I have these 3 curves. Also, I can start playing with the points and then move it non-uniform, like 3 curves. Then I would like to cover these with these. Sorry, because we have like the order of that. So we have like this one, and this one. Yeah. No, I know. Exactly. So this one and this one and this one. There you go. So based on the order of the curves that you get, so you have like the difference of the orders to cover that surface. So, huh?
What tool or yeah, like what tool would you use?
What tool?
Yeah.
So this is going to surface, and then you got the surface from 2 or 3 or 4 edges curves. So then you can do, you know, just like other things. So for example, if you would like, then you can start playing with this, and then let's say just as a kind of example, and then you have like this surface in here, and then I would like to make a loft between this one and this one, and then you cover this.
And that just well just connects like
Two or more curves. Yeah, they're making a surface between these curves.
not have thickness.
No, not the thickness. So you can offset surface, not offset surface. Then this is going to be offset surface. Enter the way that you want, like to the inside or outside. You can make a distance of 1, and then you can say that I want a solid, yes, a solid geometry. And you can say flip all to the outside. Then you're going to get a solid geometry. Or you can say that I would like to use this as the distance. Instead of 1, it's going to be 10. So I want to make it geometry and then put the columns underneath it. So what I would like to do is just like 10, and then you design something, and then you have like your building inside these two surfaces, and then your column is going to be underneath it, whatever. Okay, so let's get to something really more interesting, and that would be the surfaces. So we got the surface in Rhino, and then you would like to start manipulating those surface based on the shape and the geometries that we have. So let's say I go to rebuild this, and then you don't want to change the degree. So 3 degree 3 would be good. Change the control point if you wish along the X and Y, or U and V in a better way and in a more correct way. Then turn on the point. So this is F10. Turn on the point, and then start working with this, and then see how it works. You can sculpt whatever. you want, and you can say that, oh, you know what, I want this surface, and also uh, I have um, another surface. Then going to turn on points in this, or let's say going to rotate this. Learn this one also because we're going through that. So 180-degree, gonna rotate this guy, and then move it in here, move it up. Then you can see the duplicate the border, duplicate the border of this, so meaning that you have access to the curve around this, and then duplicate the border of this one, and you can say that, oh, you know what, I want this one and I want this one, and I would like to loft them.
If you don't just lock the surfaces together, would that be the same thing?
Loft the surface? No, surface. No, it's meshes, curves only, not the surface, not the surface. So what you can do more interesting is twin the surface if you want for your interior spaces, and then let's say number of the surface is going to be 3.
Is that like slowly meshes it?
Huh?
That like slowly like
Yes.
like trans-
Yes. It's transforming between these surfaces. We good? Okay.
Can you do like it's a you know what a Mobius strip is?
Yes.
Can you do it?
Yeah.
Can you,
So I can show you later on because it's my class actually. It's one of my assignment in my class.
oh, really?
So for the for the graduate, so they do the Mobius and then move it around and then going around.
It's like they're kind of rectangle, but both sides are like flipped. So it kind of goes like one of
Yeah.
Oh, but it's like one.
yeah, it's just one.
So
It's basically yeah.
okay. Hopefully this is going to be a kind of eye opening about what you can do with the other softwares rather than just like getting to the
Do you also know how to use what is it, grasshopper?
yeah.
Yeah.
Yeah, we started actually Grasshopper like 2 sessions ago. So you can go on my YouTube channel and then see some of like I started like 2 weeks ago my YouTube channel after like 20 years. So then yeah, I taught one of the because it was a winter storm. I taught one of the famous buildings actually how to model it in Grasshopper. Um, See if you go to my YouTube channel. I don't know if you have one.
This is Dr. Eric Barr.
That's correct.
Live right now.
Go to the yeah. Go to the live and up. Yeah, this one.
So my question is like, you can model all of these things, and it looks really cool. But how do you like relate these models to a floor plane? Like,
So you have to draw. So
would you have to like take the dimensions of like the exterior and then just put them on Revit. I've seen.
Or you can draw in here, not using Rabbit. Rabbit is good for the delivery when you're working for the company that they're sending it to the construction document for the vendors, and they would like to build something.
I'm just
But because some people they get used to not drawing anything and then put the staircase and then drag it from some type of just like library. That's why sometimes just like you don't learn how to do things. And that's and then you're limited to what they're giving
yeah.
give it to. So, but
But if you had like on the first thing or the thing that we followed along with, we had like 3 straight lines and then like a curve.
mhm.
So if we like wanted that to be planned, would we just like take those lines and copy them over to Revit to then create
No.
like a floor plan?
Well, yeah, you can do that basically, or there is other way of making things 2D. So if you wish, so even just like for the 3D geometries like this, so you can make this 2D, and then you can say that I would like to see in 2D version. So everything is 2D. Mhm.
How do you open Grasshopper? Is it like with it right now?
Yes. So this is Grasshopper in here.
Oh
It's
yeah.
like it's like purely coding.
No, it's not coding. So it's a node base. It's not a coding. So I do coding. I teach coding, but I can tell you that it's very much um like the package of the code. So it's not a code. It's the same thing that you do in Rhino. You do it with the nodes. Like for example, you have a point, or you have a point in here. And this is, let's say you have a constructing a point, and then this is constructing a point in here. Let me hide these. So this is a point of 0, 0, 0. Then I would like to make this, let's say, between then I would like to make this like 10 and 10 and 10. So now I have a point, the 10 and 10 and 10, so I can start playing with it, moving it around. Then I'm going to have like the second point in here. Then it's going to be my second point. And I would like to make a line at the 2 point. So connect these. So it's a line. Then you're moving this line, let's say along Z axis or X axis. And then whatever, let's say 20. And then this is my second line. Then I would like to loft them, the first line and the second line. Sorry, stop lofting them. So this is the first line and the second line. So, and now I would like to extrude this along Z axis with 15. There we go. So if I start changing these points, they can start, the entire geometry can start moving around. If I If I move the second series of the point, the um, shape also start changing. And then if I move the along x-axis, start changing. Or if I replace this with y-axis rather than x, so it's going to be y-axis. It's going up and down. So it's not a coding per se, but it's called visual coding. So then you start with point, going to curve, going to surface, and to geometry. So yeah,
Are you gonna open up this course next fall for undergrads?
if we have like uh, 10 people at least,
How many do you have right now?
12,
And all grad students? Is there
all grad, all grad, yeah.
did they like choose to take that or is that a requirement?
Huh?
Did they choose to like take
Yeah,
that
this is
class?
an elective course.
Okay.
Yeah, they are very enthusiastic about learning. So yeah, there is an elective course.
I would think more people would be like I really wanted to learn Rhino, but it's only us two here.
It's not